Hello, geometry students. Welcome to your lesson on indirect proof. The ALEX objectives are simply just called indirect proof. You may also hear of this called as proof by contradiction, or in some textbooks it's proof by negation. And basically what happens is there are cases in upper level, graduate level mathematics where it would be simply almost impossible to directly prove a proof. And so what we do is we go about trying to prove the opposite. And in doing so, it ends up contradicting the rules of mathematics or something along those lines, which then just leads to the only thing being left possible is what we're trying to prove in the first place. So, some notes on that. First of all, indirect proof is also known as proof by contradiction. Let me get my pen tool here. Proof by contradiction. Again, we temporarily assume what we're trying to prove is false. Then by showing that the assumption is logically impossible, we end up proving the assumption is false and that the original conclusion is true. So these are going to be 3 steps, and I've outlined the 3 steps in all the problems to make it a little easier. But step 1, state as a temporary assumption the opposite of what you want to prove. Then you're going to show that the temporary assumption leads to some contradiction. And again, it may be just a contradiction of how numbers work, the real number system, contradicts what we already know about triangles, contradicts the definitions of even or odd, just some contradiction occurs. And step 3, conclude that the temporary assumption must be false and that what we want to prove then must be true. So here is an example. Given that x is equal to 2, prove that 3x minus 5 is not equal to 10. So we are first going to assume the conclusion is false, meaning what we're trying to prove is false. So the opposite of 3x minus 5 not equal 10 is we are going to assume that 3x minus 5 is 10. So find a contradiction. Well, let's go ahead and solve. 3x minus 5 is equal to 10. And so we get 3x equals 15. And so x is equal to 5. And as we can see, that contradicts the given information. So we can point out the contradiction. So x equal 5 contradicts the given. X, it has to equal 2. Therefore, again, what we were trying to prove in the first place, before we gave a temporary assumption, what we're trying to prove, 3x minus 5 is not equal to 10, is now true. Therefore, 3x minus 5 is not equal to 10. Again, we started by trying to prove the opposite of that, but it led to a contradiction. Therefore, the original assumption is true. A second example, more related to geometry. So given that triangle ABC is isosceles, prove that the base angles cannot be 92. So I'm going to draw a triangle here, and I'm going to let B and C be the base angles. And remember, the base angles are the angles that are congruent to each other. So let's make an assumption of the opposite of what we're trying to prove. So let's assume each base angle is 92 degrees. Okay, so we're assuming the opposite of what we're trying to prove. So that being said, if we add 92 plus 92, we get 184 degrees. And that is a contradiction because the sum of three angles is supposed to be 180. Measure of angle A plus the measure of angle B plus the measure of angle C is supposed to be equal to 180 degrees. So our contradiction is the two angles add to 184 degrees contradicts it was called the triangle sum theorem. The triangle sum theorem. That all three angles sum to 180. Therefore, again, so I pointed out my contradiction, and now I state the original, what I was trying to prove. Therefore, the base angles cannot be 92 degrees. Okay, here's one for you to try. So pause, complete the question, and resume when you're ready to check. And this is supposed to be a triangle ABC. Given triangle ABC, prove that triangle ABC can have at most one right angle. Again, pause and resume when you're ready to check. Okay, assume the conclusion is false. So let's assume triangle ABC. Again, the opposite of at most one right angle is more than one right angle. So suppose triangle ABC has, let's say, two right angles. So we have 90 plus 90 equals 180 degrees. Again, that's the sum of the two. But again, the three angles, measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So again, for the same reason as the last one, two right angles adds to 180 degrees, but this contradicts the triangle sum theorem. Therefore, again, we just end with what we're trying to prove in the first place. Therefore, triangle ABC can have at most one right angle. Hopefully you were successful with that problem. So here's one more. It's in a two-column format, but it's the same idea. We're going to use the same three steps, but we'll have some additional proof, two-column proof process steps along the way. So we're given that ST is not equal or not congruent to PQ, and QS and PT are straight lines. What we're trying to prove here is QS and PT do not intersect, do not bisect each other. So again, we have our given, and same thing as in the paragraph type, we're going to assume the opposite. So I'm going to assume that QS and PT bisect each other. So if QS is bisecting RT, that would make QR congruent to RS, and PR, again, since they're both being bisected, PR congruent to RT. Again, that's listed in step 3. And that's, again, definition of midpoint is what Alex would write, so that's what I will write here, even though I like to use if-then statements, which if a segment bisects another segment, it divides the segment into two congruent parts. Definition of midpoint. That's what midpoints do. definition of bisector. Definition of bisector. If a segment bisects a segment, it divides the segment into two congruent parts. And here is a step I usually just say assumed from diagram, but we can say the angle PRQ and angle SRT are vertical angles. And that's why they mentioned that the lines were straight, so we're not wondering at all if these are really vertical angles. They definitely are. Intersecting lines form vertical angles. Again, this is something that I'd actually write assumed from diagram. You can just tell they're vertical angles. So I'd accept either of those reasons. So we know that PRQ is congruent to SRT because vertical angles are congruent. Again, it's not the definition of vertical angles. That's just, it's just a property that they hold. So I'm going to make my marking here on my angles. And so we can see that the two triangles are congruent now by side angle side. Congruence. Therefore, ST is congruent to PQ by CPCTC. Well, maybe you didn't notice, but that is a contradiction of what was given. And so ST congruent to PQ contradicts the given. Therefore, the original thing we were trying to prove is true. Therefore, QS and PT do not bisect each other. Again, strangely or oddly enough, how we proved that is by assuming that they did and came out with the contradiction to the given. So, kind of a different little lesson in the middle of chapter 5, but hopefully you enjoy doing something a little different. Good luck.